It's a little bit early, but the power just came on, so it's nice and cold in here, but we'll get this done. We're going to finish up 2.6 right now. We're going to do compositions of functions with the rest of the time that we've got in this section. So let's do that. Let's see. So 2.6, combinations and compositions of functions. Continued. Okay, the rest of this section will be looking like this. F of g composed of x, or g of g of f composed of x. Fog and golf is what I call them, but that's not what they're called. This is not an O. This is like a instead of a multiplying or dividing or adding and subtracting, it's just a little zero in the middle telling you what to do. Has to do with composition. It means that we're going to go do g of x, and then we're going to take that with us and scoot ourselves back to the f function with whatever number we got there. Over here, we're going to do f of x. You do the closest one to x first. We're going to do f of x. We're going to plug in whatever that number is, or an x, or whatever. Plug that in first, then take that number and back up and plug it into g. So it's a two-part thing to do. Let's look at it. In the next two problems, we're going to find f composed of g of x. We're going to find g composed of f of x. We're going to find f of g composed, f composed of g of 5, and g composed of f of 5. So we're going to go f of g with x and 5. Then we're going to go g of f with x and 5. Definitely doing it with numbers you'll find easier, no doubt. This is sort of theoretical. This you can hang your hat on. Let's look at what we're going to plug into. First time around, f of x will be 3x, and g of x will be x plus 7. Okay, let's first do f composed of g of x. That means we're going to start with g of x. So we're going to go to the g function and we're going to plug in an x. Well, it already is plugged in. This is g of x. So they're just asking you to grab the g of x. So we're going to grab the x plus 7. So now we've got x plus 7 in our hand. Now what we're going to do is back up and plug x plus 7, plug this, g of x, the x plus 7, plug it into the f function. So the f function, f of x, is 3x. We're doing f not of x, but of x plus 7, because we've got that in our hands. So go over on the other side, and everywhere you find an x, plug in an x plus 7. And then here's where some of you really had a struggle on the test. It ain't just 3x plus 7, it's 3x plus 21. You've got to distribute that 3. So 3x plus 21 is what they're looking for there. Okay, so we started with g of x, just go grab it, x plus 7, and then back up and put that piece into f. Okay, let's now do g composed of f of x. G composed of f of x. Let's start with f of x. Okay, go find f of x. It says it's a 3x. Take that 3x in hand, and we're going to back up and do g of x. Well, let's see. G of x is x plus 7, but we're not going to do x. We're going to do 3x. We're going to take this 3x in our hand and plug that into the g of x function. So it says to use x. Well, we're using 3x. And there we go. That's it. That's all we can do. There's nothing to do. Okay. Now, if that was a bit confusing to you or you weren't comfortable with that, no worries. We're going to do that again. But now let's do the numbers. F composed of g of 5 and g composed of f of 5. That'll feel better to you, I think. So let's look at f composed of g of 5. Okay, it says to do g of 5. So go up to g of x, And everywhere you find an x, don't use x, use 5. So 5 plus 7, that's just 12. So 12 is what we're going to take with us when we back up to f. So let's now do f of 12. And that says 3 times 12, or 36. So 36 is the answer there. And our last one in this little group, g of f composed of 5. Again, start out with the one closer to the number. F of 5. So let's go put a 5 in here. 3 times 5 is 15. So we have 15 in hand. Take 15 with you and back up to g. So g of 15 is going to be 15 plus 7, or 22. Okay, done with that group. Let's see what our next problem gives us. Here we're going to do f composed of g of x. We're going to do g composed of f of x, the same routine. Then we're going to do f composed of g of 2 and g composed of f of 2. So we're going to do both x's, and in this case both 2's. F of x in this case is x squared plus 3, and g of x in this case is x squared minus 3. So a little bit more complicated on the expression, but nothing you can't handle. Let's start with f composed of g of x. Okay, start with g of x. G of x is x squared minus 3. So take that in your hand and back yourself up to the f function. So instead of doing f of x, we're going to do f of x squared minus 3. Let me rewrite that. F of x squared minus 3. We're just going to take our g of x and take that with us to the f function. What we're doing with that, now let's go over here and do it. It says go across here, x, what is our x? It's that crap, that mess. We're going to square it and add 3. So we've got x squared minus 3 squared, that's our x, our new x, squared plus 3. Let's FOIL this out. So we're going to get x to the 4th. That'll be a minus 3x squared and another minus 3x squared. Then a plus 9, and don't forget that plus 3. So we're going to get x to the 4th minus 6x squared plus 12 for that. Okay, let's go the other direction. Let's go g composed of f of x. Let's start with f of x. F of x is x squared plus 3. So take that in hand, x squared plus 3, and back up to the g function. So we're going to be doing g instead of x. We're going to be doing g of x squared plus 3. So first we have to take our new x and square it, and then we'll subtract 3 from it. So this is a FOIL problem. X squared plus 3 times x squared plus 3, and then I'm going to have to minus that 3 right there. So I'm going to get x to the 4th, 3x squared, plus 9 minus 3. So x to the 4th, 6x squared plus 6. Okay, I want to fit the last 2 on here because we have all this mess up here for you. So let's do f composed of g of 2. F composed of g of 2. The first thing you're going to do is plug in 2 into the g function. And remember, these are going to be easier. When you have a number to grab onto, it's just easier to perceive, to follow the steps. G of 2. Okay, here's our g of x formula. Let's plug in a 2 right there. 2 squared, that's 4. 4 minus 3 is 1. So we are taking 1 with us. This business right here, g of 2, is a 1. Back up and let's do f of 1. So the f function, f of 1, is going to be 1 squared plus 3. That's 1 plus 3. That's 4. And let's finally do g composed of f of 2. Start with f of 2. Let's see, that's a little furry. Let me try to focus this. Well, that looks better to me. F of 2, let's start with that. So let's see, f of 2, that'll be 2 squared, that's 4, plus 3, that'll give us a 7 to take with us as we go backwards to the g function. So plug in 7 here in the g function. 7 squared is 49. 49 minus 3 will give you 46. So we end up with 46 there. Okay, let's finish, well, not finish this up, but let's do the last pre-graph, pre-worksheet part of this, where they're going to ask you to do the opposite. They're going to give you the composed part and ask you to break it down. They're going to ask you find f of x and g of x so that h of x is the same thing as f composed of g of x. Okay, so equals f composed of g of x. So what we want to do is we want to figure out what the parts are. They're going to give us the completed f composed of g of x, and we want to break it down. What was the f? What was the g? Let me show you the first time. You'll see that the second time is very easy once you get shown. It's one of those. So our final put together composition looks like this: 4x minus 3 to the 5th power. And our job is to come up with what was f of x, what was f of x, and what was g of x. So let me put them here. F of x equals, g of x equals. We need to fill those in. Okay, if we're doing f composed of g of x, then g of x is our first thing we worry about. So let's go here and look at what g of x was. G of x is going to be the first thing that happened in this h of x. So the first thing that must have happened was this, the interior piece. So g of x must be 4x minus 3. G of x is what we took with us, put in our pocket to go to this one. So this piece is our x when we go to f of x. And what we did to this thing was to raise it to the 5th power. So f of x would have been x to the 5th. Let's look, remember, this is like division. This is a breakdown. Let's build it up. Let's look the other direction. So if we had had this to begin with, and we were asked to do f composed of g of x, first thing we do is g of x. That would be this piece. Take that piece with you and transport yourself to f. You would be taking whatever that original piece was, 4x minus 3, and raising it to the 5th. So there we go. So the internal piece, the g of x, is always going to be the middle, the guts, the important stuff. Then the f of x, what you do second, will be taking that and doing something extra with it, something on the outside. Let's do that again. Let me give you that h of x is the square root of negative 2x plus 5. No, that's not the square root. The absolute value, it is early, the absolute value of negative 2x plus 5. We've got to come up with f of x and g of x. Okay, so this h of x represents the final f composed of g of x. So first you've got to figure out what is the guts, what did you start with, what's the core, what's the foundation of this problem. The middle and stuff, the chunk that you began with is right here, negative 2x plus 5. And now let's figure out what happened with f. What did you do with this negative 2x plus 5? You created this, you pick it up, you go with it to this final bit, you put it in you put it in absolute value bars. You put your chunk, calling it x now, in absolute value bars. So those are the two answers. Okay, let's move to the worksheet. Okay, because it's a little difficult to tell the difference here, this is f of x. I'm going to blue this one with arrows, and I'm going to orange the g of x. Okay. We have three problems here. This is an f plus g. That's not a fog or a goff. This is an f plus g. It's not a fog or a goff. And then number 3 is a fog or a goff. So these first two, we're doing f plus g of -1. They're done differently from the f composed of g. So what this is very much a distributive problem. F of -1 plus g of -1. We've done this, we're doing it now twice. So let's go over here and figure out what f of -1 is. So what you want to do is you want to go look at the blue function, the f function. They're giving you the x, you give them the y. So on the -1, let me find that on the x-axis, it's right there. Let me figure out what the y is, 1, 2. So that point right there is the one we're discussing. And when the x is -1 on the f function, the y is a 2. That point is -1, positive 2. So 2 is the answer there. They're giving us the x. We've got to give them back the y. Let's go to this part of it. G of -1. The g function is the orange one. Let's go to the g function where it is -1 on the x-axis. There's -1. We're going to have to travel down to get to its y. Its y is at -2 because where x is -1 is right here. To get to the g function, we have to go down to this point, and that point is -1, -2. They give us the x, we give them the y. 2 plus -2 is 0. So 0 is the first answer there. That doesn't always happen. That's just because of the array of those two functions. Okay, this one says find the domain of f plus g. Let's see. We've got some arrows. The f function is in blue. Let me outline that. And it is intended that this one stops here and that one has an arrow. The g function, it is intended that that one stops there and that goes on forever. Okay, we're finding the domain of f plus g. We're not finding the domain of f and then the domain of g, although we could do it that way, and I will show you that way. But what we want to do is look at it as a whole. We want to look at what is being used up on the x-axis as a whole of this one. So here's the x-axis. F is using up -infinity, but g is not. So f plus g, we're not allowed to put in anything that both of them don't cover. We looked at this in the number line situation, and we're about to look at it in the number line situation also, because that might be more helpful to some of you. But I want to show it to you visually here before we look at it visually on number lines. So f goes all the way to -infinity, starts at -infinity. But because g is limited to starting at -4, that's where the domain for the entire problem has to be. A -5 will do fine in the f function. -5 is part of the domain of the f function, but it is not part of the domain of the g. So if we're considering f plus g, our little cells have to start at -4. We can't start back here because g can't maintain that. So we're going to start at -4 for the domain of f plus g. Now let's go look out how far they go. There are no breaks here. I see no breaks. There's no gap. So we are continuous on the g function all the way out to +infinity. No problems on that one. But f limits us. F stops going out to the right at 3. I got a little carried away with my dot, but it's supposed to be at 3. So if we're concerned with the domain of f plus g, we have to stop at 3. And that's the domain for f plus g. When we were doing it on number lines, let's see what we've got here. We've got a -4 where some of our stuff stops, and we've got a 3. Okay, so let me show you. On the f function, this goes all the way to -infinity, but the f stops at 3. So the f looks like that. The g begins at -4 and goes all the way to infinity. And when we consider the domain for both of them, the domain for f plus g, we have to consider only where there's overlap, only where it's good for the blue and good for the orange. So that's this gap right in here between -4 and +3 with brackets, because it includes both of them. So that's the domain if you want to make number lines out of these domains. Whatever works for you. We're not doing a ton of them, obviously. Okay, now let's go back to what we just started with in this little section. F composed of g of -3 using the graph. Again, this isn't as confusing, I don't think, but let me still help you out here. That's the f function. And there's the g function. Okay, let's start with g of -3. Remember, f composed of g, you go inside first. So g of -3, let's see, -1, -2, -3. Here's the point we're concerned with. They give us the x, we're giving them the y. That's a 1. So we're taking 1 with us over to the f function. So we're finding f composed of that, and that we just found out was a 1. So f of 1 is literally what we're looking for. So go to the f function, go out to 1. We have to go right up to there. They gave us the 1, they gave us the x, we give them the y. So 2 is the final answer there. Okay, that's it for 2.6. Enjoy it. I hope to see you on Monday.